Hello, everyone. Thank you for having me. Very pertinent to the question that was just asked on the classifications from the gentleman over there. So that's what we'll get into today. All right, my name is Matt. I'm one of the co-founders of Taiko, which is a Type 1 ZK-EVM. And today, we'll talk about equivalence over efficiency on the ZK-EVM spectrum. Hopefully, we'll learn some new things and show why we find this trade-off attractive. So here's an outline. We'll talk about that spectrum, the ZK-EVM spectrum, why Ethereum-equivalence, Type 1 is attractive, extending the equivalence definition, Taiko's design, some counterpoints, which are useful to consider, and then a quick summary. Hopefully we have time to get through it all. I'll go rather quickly. There's a lot to cover. So here's that diagram that was just referred to, kind of a seminal diagram in the space, the classification of these ZK-EVMs. I'm sure many of you have seen it from Vitalik. If we just kind of flatten that for an easier view, we have this second diagram, which trades off Ethereum equivalence or compatibility on one extreme and prover performance, ZK proof generation ability or efficiency on the other side. So Type 1 through Type 4, going from compatibility and lessening compatibility as you go, but increasing on the efficiency of ZK proof generation. So Taiko is a Type 1. Currently, I think the only one aiming directly and initially for a Type 1. Others fall along the rest of the spectrum. What are the benefits of Ethereum equivalence? We believe it is the best developer experience. We believe there are network or chain benefits, not network as in network effects per se, but of course that as well, which is more part of developer experience, but actual chain benefits. And we might get into a few others. So the best developer experience, I think many of you are familiar, it all just works. That's really what we give up the trade-offs for. All contracts, code once, deploy everywhere, all dApps, all tooling and infrastructure, best practices and patterns. And that last point is important, no edge cases or need for re-audits. Because a lot of our peers will, they'll all talk about the best developer experience, supporting EVM at different levels of compatibility, but it's really the need to reduce that cognitive burden and removing those edge cases, which are important, we find. Some examples where those edge cases might rear their head, and this is taking the kind of conservative case, so a Type 2. So the least difference. As you go out the spectrum, there would be more instances where differences rear their head. But for us, that means where Ethereum Solidity contracts, if deployed to a Type 2 or plus, would fail is if those contracts rely on gas costs in some way, and if they rely on the block hash for reading a past state. So those are just two instances, and when that happens, you might have overlooked that, but that could cause your contract to fail. And of course, again, as you go further out from Type 2.5, 3, and 4, there'd be other instances where, but on Taiko and on Type 1 ZK-EVMs, you just don't need to worry about these edge cases. Code once, deploy everywhere. We've seen that, and really our ethos is kind of embodied in this. We think it's quite simple to use Ethereum, kind of in the middle. There's definitely reasons to want to vary and change some things, but we believe then it all kind of comes back to Ethereum, and that the devs and the users have spoken as of now. So, all right, this is maybe a bit less known than all the compatibility on the contract and dApp level. Some chain benefits. Maximum, so besides the EVM, we also implement all surrounding Ethereum architecture as is. So state trees, hash functions, precompiles, and because of all that, we get some really nice properties. So maximum reuse of battle-tested infrastructure and components, security benefits, and some superpowers from equivalence. So maximum reuse of all the infrastructure, that means we get to reuse execution clients with a minimal diff. Right now we use Geth with a very minimal diff that we expose on our site that you could follow along. We get to reuse PBS infrastructure, proposer builder infrastructure, like MEV Boost for building blocks. And we get to use account abstraction infrastructure and components following the 4337 spec. So again, just by following the Ethereum spec perfectly, we get to reuse so many of these battle-tested solutions and kind of this huge tailwind that the Ethereum ecosystem at large has built for us. In terms of security benefits, this is maybe a more subtle point, but with a minimally changed node, we find there's less surface area for attack. So yeah, you're just using these like really battle-tested, client implementation. And then on top of that, you could do something like use SGX proofs to prove that execution in addition to ZKPs. So not instead of, but in addition, because of that really battle-tested client. We find that's a security benefit. And then some superpowers from equivalence. I'd say these are maybe the most unique things or less spoken about ones, but we have some really nice cross-chain communication affordances. Because we use Merkle-Patricia trees, we could use Merkle proofs to speak to Ethereum really easily, both ways, with these Merkle proofs. And we also have a nice path and a very simple path for L3s, or what we call inception layers, just because you could deploy Taiko as is on top of Taiko. Because the L2 emulates the L1, it's quite suited to support the L3 above it. So the L3 to L2 relationship maps nicely to the L2 and L1. Of course, you could also deploy a lot of L2s and have some nice properties like aggregating their proofs and stuff like that, to be determined what is more compelling for the market. Again, PBS using MEV-boost, and builders and searchers reusing their same block building algorithms. Because we're executing Ethereum blocks, searchers, builders could build their blocks as is according to their algorithms, use that same out-of-band MEV-boost infrastructure, and yeah. And then because of that, we also have an easy path for account abstraction. Because these searchers and builders, if they're keeping the account abstraction user operations in mind, then again, we just kind of get that natively, because the builders and the searchers are cognizant of that, and we get, if they're following the 4337 spec, then we get that. And then the last one, maybe many of you have heard about it, based rollups. That's something we get, which is a super important property for us. That actually doesn't stem purely from the Ethereum equivalence on like the EVM and the Ethereum architecture side. You also need another property, which is permissionless proposers. So the base rollup means that L1 validators could be your L2 proposers or sequencers. At Taiko, we call the sequencers proposers, but if it's permissionless and it's the same execution environment and there's PBS, then builders and searchers could craft L2 blocks, include them in their L1 bundles, if the MEV is worth the squeeze for them, and give that to the L1 validators to include in the L1 block. So these are some nice superpowers. We can actually extend some of those superpowers, not the ones we kind of get for free, but this is a research post by my teammate Brecht, who's here, which is using our equivalence and kind of putting forth an idea for a precompile that will even augment the cross-layer communication. Could link to this later, but it's a nice way to even go above and beyond what the current cross-chain communication allows. Okay, so we went over the developer experience benefits and then like the chain benefits, but then I also like to talk about emotional benefits, which is less spoken of perhaps, but also super important and unique to us at least at this point. So we've seen how we benefit, or type 1s could benefit from Ethereum. All the specs, all the clients, the tooling, we get to reuse it all, battle tested. But type 1s also benefit Ethereum in a special way, because we are proving the Ethereum environment as is. That means we're kind of doing a service for the eventual goal of proving Ethereum L1 blocks as they are, or for like a snarked L1, right? Where L1 blocks are proven, and then validators just verify the proofs. What some people would call part of the end game for Ethereum L1. So And even before like a snarked L1, it's also a bit of a stepping stone for enshrined rollups. Forget proving L1 execution, if Ethereum wanted to enshrine a rollup for certain reasons, then Taiko is a pretty good spec to, not to say that Taiko would be the enshrined one for, perhaps social reasons and other reasons, but Ethereum could kind of give birth to an enshrined rollup that really follows the type 1 spec, the Taiko spec. So I call this emotional benefits because it's really important to us that what we're doing, we feel contributes to Ethereum, and gets them closer to, gets us all closer to the end game and the properties we care about. So yeah, that's a nice emotional benefit, I find. All these L2s kind of cater to Ethereum, use Ethereum, so it's really meaningful to be a type 1 and kind of execute those blocks and be able to contribute some meaningful work. Okay, a little detour just because, I had these confusions when I was just starting out. What are the difficult parts to prove? We talk about you lose the efficiency. Some of the things that are ZK unfriendly on Ethereum are the Keccak hash function, notoriously, the Merkle-Patricia tree structures used in state trees and transaction trees, and certain precompiles. These are the things that those peers or other design decision rollups do away with to varying degrees, but we keep in. These are what we have to really kind of jam in to the ZK-EVM, black box, so to speak, that was not really made to be proven efficiently. So in a sense, one way that I like to conceptualize it a bit is there's a lot of hard work from our ZK engineering team right now on the circuit side, but then kind of simple everywhere else with the clients and all the reuse of the components. And then again, like simple ever after for devs and users and the network participants running those nodes and running those infrastructure. So that's just a quick detour if anyone is curious. Okay, now I just laid out some arguments or some different components. I'd like to provide some supporting arguments for these beliefs. So the first one, supporting arguments for UX over everything. I find the success of optimistic rollups has shown that EVM equivalence and frictionless UX are key, right? Optimistic rollups have 80+% of the market right now. Obviously, they've been around longer, but enough so to overcome any of the perceived drawbacks, like the long delay periods to wait for the fraud-proof window. So if we kind of take that for granted empirically, then I kind of like to think about type 1 ZK-EVMs as optimistic rollups in that they get to that perfect equivalence, perfect compatibility position, but then we get to add greater security guarantees from the use of validity proofs and some other things, arguably, faster transaction finality, not having to wait the 7 days, but a much lesser time, greater ability to scale at scale, because the nice properties of ZK rollups to amortize the proof verification cost when you pack in more transactions, greater interoperability, and greater ability to decentralize. That one requires some nuance, but if anyone's interested, we could talk about that after. I guess we have a break coming up. So I really like to think of type 1 ZK-EVMs as optimistic rollups, the tried, tested, empirical. Everyone loves that UX and equivalence, and then we get the nice properties of the validity proofs. Now, supporting the arguments for being okay with the less efficient ZK proof generation. So the thing we sacrifice, these ZK proving times and cost, for what it's worth, we mostly care about cost. We talk about time and like general efficiency, but when the rubber hits the road, we care about cost. Of course, like they're kind of two sides of the same coin, but you could throw more compute at it to speed up the time, but if it's all for like a big cost, that won't do because it all kind of trickles up to user transactions in the end. But, so given that we sacrifice that, the thing that we sacrifice will continue to improve so rapidly thanks to advancements from hardware accelerators and some software optimizations and new proof systems that don't just come from our ZK engineering team, but that come from the whole industry, right? We can't even keep up with the pace of all the ZK innovation. So that's a huge tailwind, I find. The thing that we are kind of giving up is really, we're on like this crest of this innovation that the whole industry could help us kind of overcome together. But while our compatibility, perfect compatibility equals equivalence. So we're kind of very comfy on that side of the extreme, and we could incrementally eat away at the give up with the help of the whole ZK and Ethereum spaces. And then finally, ZK proving time really matters only when you're trying to talk to another chain, when you're trying to bridge out or do some other type of message passing to another chain. Again, we saw that optimistic rollups provide evidence that users are happy to, if they don't want to wait those 7 days, they pay an LP bridge for like a fast path, paying a few basis points to get out. So that's one thing. So yeah, if users are willing to wait that time, then surely, we don't have benchmarks that we could provide with our full faith behind it, but let's say on the order of an hour is what they'd have to wait to go that, that validity proof to the bridge way. However, there's also even benefits to that, or we could even increase that trade-off the good way from some clever little schemes. I call it a sidecar proof. It's also from my teammate Brecht in the audience. Basically, for withdrawals, there's some little clever tricks you could do. Like, you don't need to prove the full ZK-EVM, the full EVM execution. If you're just trying to get withdrawals, you could do some tricks that, okay, Alice owned 10 ETH, she didn't spend, X in all this time, and then when she wants to withdraw, you could just kind of run over the intermediate transactions, and you know that she could get out quick. So you're doing like this sidecar proof. So you don't have to generate the full ZK-EVM proof. You kind of get out quick, just proving that the withdrawal is valid, that the user has enough stuff. So again, kind of overcoming the big give up is really nice. Okay, now finally, into the last end of it. We've covered equivalence on the EVM and the Ethereum architecture side, but what if we extend it to other Ethereum properties of decentralization? Not the architecture, but decentralization for proposing and proving. Can we do that? Yes. In fact, Taiko does that. This is not part of the canonical type 1 definition that Vitalik talks just about the architecture, but if we extend it, which I'm kind of proposing here, then we get some really nice properties. So with permissionless proposing and proving, we could lead towards a decentralized tendency and have the properties of Ethereum also, which is censorship resistance and liveness, right? If you think of Ethereum, we all love the censorship resistance and the liveness. So if a rollup implements that, then I'd say that's even like more Ethereum equivalent. And as we learned, we have a really nice path for max censorship resistance and liveness by using who better than L1 validators via based rollups. So I like extending that definition, and that's indeed what Taiko does, because those are important properties to us. So not just the type 1, but also the decentralized proposers and provers. And then if we just extend it a bit further, I mean, this is a bit more hand-wavy, but again, all in line with Ethereum-equivalence, community-centric Ethereum ethos, everything we do is open source. We empower contributors in some meaningful ways. We build together with the EF, specifically their PSE unit, and other great roll-up teams. And together we move Ethereum closer to its goals. So that's kind of like that third leg of the stool, which is in my personal definition of Ethereum equivalence beyond the EVM and surrounding architecture. So if you kind of hit those 3 points, then I like to think of it like this. They're the same picture. And here I just repeat that. That's exactly what we do. We try to do it technologically and ideologically on the type 1 stuff that we spent most of the time talking about, but then also on the provers and proposer side from day 0. In fact, right now in our test nets, it's permissionless proposing and proving. There's been a couple thousand proposers and a couple hundred provers that participate. So no centralized sequencer from the get-go. We're really keen on that. There's some counterpoints. I'll run through these very quickly. We love having fruitful discussion about what are the other options we're not pursuing. Some of the counterpoints, which are reasonable, are, hey, it's a new design space, build a better VM with better developer experience. Type 1 may be infeasible, it will be too expensive, right? That's our challenge we seek to solve. Some people say rollups already pay Ethereum for security, data availability, and settlement, so kind of go crazy on the execution environment, really depart from the rest of it. Some people will say, again, going now to the proposer and prover side, users want centralized sequencers. They love those fast, soft confirmations. They might not care about the censorship resistance and liveness of the L1. And then, just relax with all the Ethereum stuff is perhaps a counterpoint. But so hopefully, maybe you've learned enough or seen enough that you have some answers to these counterpoints. But again, different and broad design space, so that's all good for others to pursue. And yeah, so that's just a quick summary. Ethereum-equivalence is attractive for developers, users, the chain and its participants, node runners, proposers, and provers, and Ethereum itself. And if we extend equivalence to mean the other Ethereum properties of permissionlessness, we get even more powerful outcomes, like the base rollup for censorship resistance and liveness. And that's it. Thank you very much.
Thank you, Matt.